Question 10, we need to do some vectors and mechanics. It says express the velocity in terms of time here. Now it's talking about mass and force, velocity and position vectors. If ever something's talking about mass and force and either acceleration or velocity, you can be pretty sure you're going to need to use F equals ma. So I think we can start by writing down resultant force equals mass times acceleration. Whenever you use F equals ma, remember it's always the resultant force that you're talking about. In this case, there only is one force, so it's fairly straightforward. The resultant force is 9 minus 3. The mass is 3 kilograms, and the acceleration we don't know, but we can work it out from this equation. If we just divide both sides by 3, we'll get that the acceleration is 3 minus 1. So that's going to be useful, because to find v in terms of t, we can just use v equals u plus at now. And u, I've been circling everything here. Oh, u is this. So u is 1 minus 2. The acceleration, we've just done it. It's 3 minus 1, and the time is t. So that's the answer really. You could just make it look a little bit nicer by writing it like this: 1 plus 3t minus 2 minus t. So that is the answer to part 1. Part 2, it's talking about speed. Now remember, speed is the modulus of the velocity, and so the speed is going to equal the modulus of our previous answer. Excuse me. So if we do the modulus of this, we know that's got to equal 5. The speed is 5. To do the modulus, we use Pythagoras. So we're going to do 1 plus 3t all squared plus minus 2 minus t all squared. And so let's square both sides. So 25 equals, we can expand the brackets, expand the first bracket, and we're going to get this, expand the second bracket, and we're going to get 4, and then we're going to, what's that? That's going to be 4t, I think, here, and then plus t squared. So this is going to be a quadratic, 10t squared. Let's just get it to equal 0. So we've got, that gives us 10t squared. This gives us 10t, and then 1 plus 4 is 5, but subtract the 25 and we get minus 20. Let's just divide by 10 because we can, so that will give us that, and then that does factorize pretty easily, but you can use your calculator if you like. That would factorize to be t minus 1, t plus 2. So the time is either 1 or minus 2, but you can't have negative time. So the answer is t equals 1 when the speed reaches 5 meters per second. In part 3, we need the position vector when t equals 2. So we'll do that up here. Don't forget that from part 1, the velocity was 1 minus 3t minus 2 minus t. When we're talking about position vectors, it's the displacement we're going to need to work this out. And so we're going to need to use s equals ut plus half at squared, I think. And this is going to give us our displacement from the start. So if we substitute in our values, we know that the initial value of the velocity is 1 minus 2. Oh, that made a mess of that. 1 minus 2. And we know the acceleration. We did that in part 1 as well. The acceleration was 3 minus 1. And so we're going to get this. It tells us that t equals 2. So when t equals 2, this value of the displacement is going to be, well, let's just work it out. We're going to have 2 times by 1, so that'll be 2 over minus 4, plus all of this times by 4. So it's actually 2 minus 4 plus 6 minus 2, I think. Just double that vector there, and so that will be 8 minus 6. That's the displacement from the start. But then you have to bear in mind that we didn't actually start from 0, 0. Instead, we started at the position vector 2, 3. So when t was 0, we were at the position vector 2, 3. After 2 seconds, we're now at this. So we've now gone this displacement. So our new position vector can be found by adding these two vectors together, where we started from, which was 2, 3, plus the displacement we've got now, and that will give us 10 minus 3, which is the excuse me, which is our position vector of p after 2 seconds.